Welcome to the tutorial room. Select a top Chapter 8. Section 8.2, Algebraic Expressions. In this section, you'll learn the definitions of the parts of an algebraic expression, including terms, variables, coefficients, and constants. We'll also teach you how to evaluate an algebraic expression by replacing the variables with real numbers. History. In abbreviated Babylonian algebra, words were used to represent unknowns. For one unknown, sidi, side, was used as we use the letter x, and mer, square, as we use x squared. For two or three unknowns, Babylonians used length, ush, for x, width, sag, for y, height, kush, for z. This led to area, asha, or length times width, for x times y. You can see the unique phrasing of many Babylonian word problems in this example. Subtract the side of the square, sidi, from the area, asha, and the result is 870, which translates to x squared minus x equals 870 in modern symbolic notation. Algebraic expressions are made up of terms separated by plus or minus signs. The terms may consist of the product of variables and coefficients, or a constant. Letters represent variables in algebraic expressions. They're called variables because their value can vary. Coefficients are the number part of terms with variables. Negative coefficients can be written as -1 times the absolute value of the coefficient. A constant is the term that consists of just a number, a term without any variables. It's called a constant since it contains no variables, so its value cannot vary and remains constant. Example 8.2.1. Describe the parts of this algebraic expression. 5x squared y minus 4xy plus x minus y plus 6. Since subtracting is like adding the opposite, think of this expression as the sum of these five terms. 1. 5x squared y plus 2. Negative 4xy plus 3x plus 4 negative y plus 5, 6. Click on each term above to hear more about that term. Terms. There are 5 terms in this expression. Variables. The variables in this expression are x and y. Coefficients. The coefficient number part of the first term is 5. Constant. The constant in this expression is the 6, the term without a variable. Since the fifth term contains the first term is the product of the factors 5, x squared, and y. The coefficient of the term is 5, and the variables in the term are x and y. The second term is the product of the factors -4, x, and y. The coefficient of the term is -4, and the variables in the term are x and y. The third term is the product of the variable x and an understood coefficient of 1. The fourth term is the product of the variable y and an understood coefficient of -1. Since the fifth term contains no variables at all, it is a constant term. Evaluating algebraic expressions. We learned in the last section that letters represent variables in algebraic expressions. That is, letters are numbers in disguise. They're called variables because we can vary their value by substituting different numbers for the letters in an expression. When we substitute a specific value for each variable, letter, in an algebraic equation, and then perform the indicated operations, it's called evaluating the expression. Here are the steps for evaluating an expression. 1. Replace each letter in the expression with the assigned value. To make calculations clear and prevent errors, always enclose the numbers you're substituting inside the parentheses. The value given to a variable stays the same throughout the entire problem, even if the letter occurs more than once in the expression. However, the value assigned to a variable can change from problem to problem, since variables can vary. 2. Perform the indicated operations to find the specific value of the expression. Example 8.2.2. Evaluate 2x cubed minus x squared plus y for x equals 3, y equals negative 2. Example 8.2.3. Evaluate 2x cubed minus x squared plus y for x equals negative 3, y equals 2. Compare the result if we evaluate the same expression with opposite values of x and y. Two x cubed minus x squared plus y equals 2 times 3 cubed minus 3 squared plus negative 2. Replace each x with 3, each y with negative 2, equals 2 times 27 minus 9 plus negative 2. Perform the indicated operations. Equals 54 minus 9 plus negative 2, equals 43. Compare the result if we evaluate the same expression with opposite values of x and y. 2x cubed minus x squared plus y equals 2 times negative 3 cubed minus negative 3 squared plus 2. Replace each x with negative 3, each y with 2. Equals 2 times negative 27 minus 9 plus 2. Perform the indicated operations. Equals negative 54 minus 9 plus 2. Equals negative 61.
To illustrate the importance of enclosing the substituted values in parentheses, evaluate 5 minus x squared for x equals negative 2. The correct approach using parentheses would be 5 minus x squared equals 5 minus negative 2 squared equals 5 minus negative 2 times negative 2 equals 5 minus 4 equals 1, the correct answer. The incorrect approach without parentheses would be 5 minus x squared equals 5 minus negative 2 squared equals 5 minus negative 4 equals 5 plus 4 equals 9, the incorrect answer.
In the resulting expression on the right, it's difficult to keep track of the negative signs and the indicated operations. It's easy to see how errors can occur without parentheses. Here, try these practices. Yes, you are right. Good job, you're right. Good job, you're right.